Okay, hello everyone. We're just going to review probability of multiple events. Today's video is very similar to the presentations from yesterday, okay? It's very similar. It's just kind of presented a little different way, maybe to help some of you. Again, it's the same essential question. How does the relationship between two events affect their probability of occurring? Again, we're looking at the probability of multiple events. Again, there's random events, guys, all over the place. And you kind of got to get a feel for them. All right? Random event is like tossing a coin, throwing the dice, a lottery, picking from the lottery. An event, then, is like getting a tail when you toss a coin, or rolling a 5, all right, when you roll a dice, or choosing a king. All right, rolling an even number. All right, those are called events. Again, there's 3 types we talked about: independent events which one does not affect the other; dependent events, sometimes we call that conditional, and we're going to look at that next week, where an event is affected by other events; and mutually exclusive, where events can't happen at the same time. All right? Events can be independent, means they're not affected by other events. All right? A coin does not know that it came up heads the first time. Okay, I got myself out of the way here. Again, guys, just because I flipped the coin and it came up tails, 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 that doesn't mean it's going to come up heads next. All right? We used to say the dice has no memory. All right? Just like a coin, it has no memory. It's the gambler's fallacy. All right, some events are dependent, which means one does affect the other. All right? An event is affected by some previous event, like drawing 2 cards from a deck. All right? Because the second choice, there are less cards in the deck. It changes the probability. And again, the chance of choosing a king, all right, if the first card is a king, the chance of choosing a king, the second card, is a lot lower, because you already took one out. But if the first card is not a king, the chance of choosing a king the second time is a little bit higher, because you're only choosing out of 51 cards instead of 52. All right? I'm going to talk about replacement and without replacement. Again, you put the cards back in the deck, then each draw is independent. But without replacement, the events become dependent. Now, when we have dependent events, it helps to make a tree diagram. And guys, we're going to be making some tree diagrams also next week too. I just want to show you what one looks like here. Again, if you play soccer and you like to play goalie, all right, but your coach, the probability of him putting you in goalie, all right, is lower. If it's Sam, or if it's Alex, then it is Sam. Okay, you have 2 different coaches, and Sam is the coach more often. All right, so you first start here. You build the tree diagram. Sam is the coach 60% of the time, and Alex is the coach 40% of the time. All right? If Sam is the coach, you have a 50-50 chance of being the goalie. But if Alex is the coach, you only have a 30% chance of being the goalie. So you have 70% chance of not being the goalie. Okay, that's known as a tree diagram. We'll work with them next week. Guys, mutually exclusive means you can't get both events at the same time. All right, either one, but not both. Okay, turning left or right at the same time. You can't do that. You can't get heads and tails at the same time. You can't get a king and an ace at the same time. All right, but you can get a king and a heart at the same time, because you could choose the king of hearts. So to get a king or a heart, is not mutually exclusive. All right, the probability of multiple events. Again, let's just review. What is probability? It's the number of ways that some event can happen, the one you're measuring, over the total number of possible outcomes, or the total number of possible events. Again, the numerator is a subset of the denominator when you're calculating probability. An example here, 4 kings in a deck of 52 cards. What's the chance of picking a king? Well, it's 4 out of 52, or 1/13. Guys, when two events, let's call them A or B, if they're mutually exclusive, again, it's impossible for them to both happen at the same time. So the probability that A and B happen is 0. All right, but the probability that you get a king and a queen, as an example, at the same time, it's 0. All right, but the probability of A or B, you add up the two. All right, we talked about that. The probability of A or B is greater than the probability of either one by themselves, because it could be either or could happen, okay? The probability of A or B equals the probability of A plus the probability of B. An example, king or queen. All right, there's 4 kings in the deck and 4 queens in the deck. All right, so it's 1/13 for each one. So the probability of getting a king or a queen is 1/13 plus 1/13. That's 2/13. Okay, that's the probability of getting a king or a queen. Moving myself around here. And again, we talked about this notation with the Venn diagrams. Instead of using the word and, sometimes we have the upside down U, all right, which is the intersection. Instead of using or, sometimes we use the symbol U. A right side up U means union, means either or. Okay? Just to keep that in mind. Again, the probability of picking a king and a queen is 0. But the probability of picking a king or a queen is 2/13. All right, scoring goals. If the probability of scoring no goals is 20%, and scoring exactly 1 goal is 15%. That happens. In soccer, a lot of times it's very low scoring. The probability of scoring no goals and 1 goal is 0. It's one or the other. But the probability of scoring no goals or 1 goal is 35%. Okay? Again, it's written like this. The intersection of those two is 0, but the union of those two is 35%. We also talked about not mutually exclusive. All right, like the king and the king and the heart at the same time. All right, hearts and king together, there's only one king of hearts. All right, so hearts or a king, there's 13 hearts and there's 4 kings, but that counts the king of hearts twice. So you have to subtract out again the 1 extra king of hearts because we added it in both sets. All right, and again, you can count them actually to realize what that is. That's the same formula. Again, guys, I'm running out of time, so I have to get going here. It's the same formula. Again, this is the union of A, B. The probability of A plus the probability of B, but you have to subtract the probability that they both happen, the intersection of those two probabilities. Again, a final example. 16 people study French, 21 study Spanish, and there are 30 altogether. What's all the probabilities? All right, again, the French only is 16 minus B, and the Spanish only is 21 minus B. But there are some people in the middle, B, we'll call it both. So you can work it out here. Again, I have to rush here to get through the end. So the B is 7. And I'll move myself over here so you guys can see that example. Against the probability it's French is 16 out of 30. The probability it's Spanish is 21 out of 30. French only is 9 out of 30. Spanish only is 14. Once you get the Venn diagram, you can fill it in. You can see everything. All right? French or Spanish, that's all of them. And French and Spanish is just in the middle, 7 of them. Okay? And the formulas all work. They all check out. Guys, just a summary again, just to show it to you. And I have to stop the video. You can stop and take a look at the formulas. All right, thank you.